So, as the search for Nemesis enters high gear, one key question is where to look. Luckily, scientists understand how binary stars orbit each other, and they can apply this knowledge to the search for Nemesis. If both the Sun and Nemesis were of equal mass, they would orbit each other in a vast but equal circle, and the search for Nemesis would be relatively easy. But binary stars are rarely equally sized.
10 or 20% of binary stars have two components where the stars are really on an equal footing. And then there are also a large number of stars where one star is considerably more massive than the other.
When binary stars are of different sizes, the smaller star, in this case Nemesis, swings in a wide orbit around its larger companion, in this case the Sun, which barely seems to orbit at all. Why does the smaller one move in a much wider circle? The answer has to do with a concept called the center of mass. A pair of gymnasts on a balance beam can help us visualize how it works.
Stars in a binary pair orbit around their common center of mass. If two stars are about the same mass, they orbit around an invisible spot in the middle, right in between the two of them, just like Tammy and Carly are balanced on the seesaw. Wow, are you guys balanced?
But unlike these gymnasts, Nemesis and the Sun are not equal. Astronomer Richard Muller estimates that the Sun has 10 times more mass than its undiscovered twin. And when one binary star is larger than its sibling, the center of mass between them shifts closer to the larger star.
So Tammy's going to help illustrate that. Tammy, how much do you weigh?
About 130.
About 130. And we have weights at this end that are about 35 pounds. So you're just a little bit less than 4 times that weight. So climb on up. Let's see where you have to be to balance the balance beam.
Since Tammy weighs about 4 times as much as the metal weights, she must move far closer to the center of mass to maintain balance. If Tammy and the weights represented binary stars, the weights would orbit far out in the distance, while Tammy would barely move. In fact, both would be orbiting each other.
It's kind of a misconception to think that the more massive star doesn't move and the less massive star just goes around it. In fact, they're still both orbiting the common center of mass. The more massive star moves less, and the less massive star moves more.
This insight is key to calculating where Nemesis might lie in relation to the Sun.
We know it's a 26 million year period. That tells us how far out it is. It has a radius of about a little over light year. So we know the orbital size.
Now that scientists know roughly where to look, the search for Nemesis is in full swing. And so far, that search has led to an astounding new theory. Not only might the Sun have an undiscovered twin, the solar system may be harboring a massive undiscovered planet.